So in this video, I'm basically just going to show kind of how to resize plots, stuff like that, and also how to save plots. So we'll start with a regular plot. We'll start with, I don't know, I think I'll do an X and a Y actually, because it'll save me from doing a bunch of random values. So we'll say 1, 2, and 3, really inventive there for the X. We'll say Y is equal to, I don't know, 5, 10, 20, right? Need to get rid of that. Let's say plt.plot. I'm just going to do a regular plot for now. I'm going to plot the X against the Y. There's not going to be a title or anything. I'm just going to show that. Okay. Let's run that. You can see here I've got this little plot here, but it might be nice, for example, because we've got, a larger Y value, to have a taller plot, a higher, a y-axis that's larger than the x-axis, or much larger than this current y-axis, right? Or you might want to make this x-axis larger, i.e. make this wider rather than taller, okay? And there are ways to do that. Now, I'm going to look at my plots here. Just because you probably can't see my plots all that well here. From the future, I'm going to do that. I'm going to look at these plots here. But anyway, if we want to actually make like a different aspect, a different ratio chart, we can use something called figure, right? And in figure, we can use something called fig size. Okay, fig size. And we say fig size is equal to, which is basically an argument of this figure function, right? And in here, we're going to give two figure sizes. The first one is the x, i.e., the width of a plot. And we're going to say we want it to be 10, right? I think these numbers, these plot numbers, actually relate to inches. So this is how many inches long we want our plot to be. But here, because I'm in Spider Python IDE, it just prints this tiny little out to this tiny little console, whereas with a normal Python idle console, we'd get a much bigger printout. So bear that in mind when you're watching this video. But anyway, I'm going to say that, yeah, we want it to be sort of 10 wide, and we want it to be 3 high, right? So you remember this 10 represents the x-axis, and this 3 represents the y-axis, right? Then we're going to say plt.plot x and y, and then plt.show. Now, you want to put your figure, your plt.figure, before your plot or before your bar chart or whatever, because if you don't, there's a chance that you won't get the figure resizing that you wish. So remember to put this line, the figure line, above whatever plotting line you're using. That being said, I'll just run this and hopefully we'll see the difference here. So you can see here that this one's ratio is different. Now, it's a bit shorter than this one, which tells me that the default plot size is probably higher than 3 for the y-axis. But the x-axis is a little bit wider now. It looks like, I think it's probably 6:6 is the aspect ratio, something like that. And so by using the fig size, we can change basically the ratios. You see that? You can basically change the ratio of the x to the y. And when you actually convert it to image, depending on the size, well, actually, I think image is just, all plot images are just the same size, just the ratio of the x to the y is different depending on how you've used the figure size reshape. But in the console, you can actually see that this chart is larger in the console, right? Now I'll show you another sort of fig size scaling up. So we'll say plt.figure. And actually, you know what we'll do? I'll actually plot this x and this y. I'll put the figure below it, and you'll see that it hasn't actually changed anything. I should have copied and pasted that really. Don't matter. I'm there now. plt.show, and if I just run this, what you'll see is, you see how this has given me a figure sized 720 by 216 with 0 axis. What it's returned there is the figure size of a plot, because it's loading a figure size for the next plot that I enter into Python, but it hasn't given me the plot, so it's just returned the dimensions straight after returning the plot, right? If you go up here, we didn't get such a return, we just got the plot here, right? And that's because we put plt.figure before plt.plot, right? And so we got a proper plot. If you don't put this figure before the plot or the bar thing, you'll not get the right figure size. You'll get a figure size change. Okay, so we'll copy and paste, not that, we'll copy and paste the correct one actually. Saves me from deleting a few lines. And instead of plot, we'll change plot to bar, just so you can see that it still works here. In fact, we'll actually change the figure size. We'll make it ridiculously long, just so it's kind of exaggerated. And you can see we got this super wide x-axis, and it looks like we've got a really large sort of x-axis and a really squashed chart, just because of the way we've refigured it. And as you can see, this plot is far larger than the one above it, or even this one, right? So we can change these values, we can mess around with them, basically to sort of produce a bigger plot or a different sort of shape of a plot. So we'll do 10, 10. We'll put the x to 10 and the y to 10, and we'll see what that produces. Oh, did I just delete that? I think I did. Let's undo that. Supposed to run it, but I deleted it. So now you can see we've got a plot that's a bit larger and a bit wider at the same time. But here in these plots, in this spider interface, it doesn't really show much of a difference, you know. So there's one more argument as well that this figure function has that might be useful to you, might not be useful to you, and that's called DPI, which is actually, I'm not sure what DPI stands for, but I think it's something to do with like the dimensions of the pixels or the pixel density or something like that. Basically, it'll make your charts bigger. I think the default is 72. Anyway, we're going to copy and paste this thing here just because it's easy, it's right there. And what I'm going to do is I'm going to add this argument, this DPI argument, right? I'm going to say it's equal to 72. Right? Let's see what kind of difference we've got in the plot size. And the plot is exactly the same size. And you're probably thinking, you've made a bit of an error there. You look like an idiot. You're supposed to be teaching us how Matplotlib works, and you can't do anything. So, the default pixel density of Matplotlib PyPlot charts is actually 72 dpi. So if you make the dpi higher, you'll get basically more pixel density, which will just result in a larger chart, basically. And if you set it lower to say 20 dpi, you'll get a smaller pixel density, i.e. a smaller chart. So if I copy and paste this again, and the reason I'm copying and pasting the same figure size is just so you can see only the DPI change difference, right? Rather than the structural change difference. So now, because the densities change, we've got a really small chart, and also it's less detailed because there's less pixel density. You know, there's less. I think it's pixels per inch, something like that. So you can't make out these numbers in the plot. That's the normal pixel density. You see the one above it that hasn't had a pixel density defined for it. It's exactly the same, and that's because the pixel density defaults that. But as soon as I go to a low pixel density, I just can't see the numbers. It's just not, it's just not displaying properly, right? Now, if I do this again, and I change the pixel density to 300, it might actually take me a bit of time to run because I've got a slow, terrible computer. Yeah, it's taking a bit of time. It is absolutely gigantic. And it's detailed enough that I can see all the pixels properly. So yeah, there's actually two sort of important arguments when you're making figures and when you're making plots, sorry. And, you can use whichever of these you want. Now, you're probably thinking, how do I save images? There's actually, well, with Spider you can actually just save it like that, but most of you probably don't have a console that allows you to just save an image manually. And the other thing is, let's say you're making like 1,000 images in some massive, I don't know, just some massive, what should we call it? A massive for loop, right? You're trying to make, yeah, a bunch of things in a massive for loop, right? You don't want to manually save all 1,000 of those, right? What you want to do is you want to make a for loop that saves it all for you, right? You can only do that if there's a save function, right? Because it saves you from bloody manually saving 1,000 or more images. You don't want to do that, right? So there is fortunately a way to save these figures, right? So I'll show you that. Just copy and paste this. We'll put the DPI. We'll get rid of the DPI and we'll just put it as normal. And I'm not sure if you do this after or before. I think you can do it before or after actually, but we're going to use something called save fig. What you do here is you just put the file name. I'm going to just call this a bar chart. Nothing special. When I run this, it should give me a PNG file. And where it saves to, and the reason why you might have seen me changing directory, is it saves to the directory that the Python file is run from, and I'm going to run it from here. And then we should see the image in here. If I use F9, there we go. So I've actually got my bar chart. Turns out you can get the bar chart without using the plt.show command. So that's useful. So what do I get? What do I get? So you see I've actually got a bar chart there, right? Now, what happens if I save it with a higher DPI? I don't know. I'm not entirely sure. I can save it with a lower DPI, so you can actually change the DPI and use this DPI argument as a save figure argument, which is the reason I got rid of the DPI. So here, put DPI is equal to 20. And we're not going to call it a bar chart. We're going to call it a bar chart 2, right? When we save it, let's have a look here at a bar chart 2. You can see it's a bit smaller and the quality of it is terrible because it's got a lower density of pixels, right? Which is not necessarily what we want, but it's handy, for example, if you want to save something at a lower, higher DPI than the actual figure is represented in, right? Now, you might have noticed this automatically saves as PNG files. I'm not entirely sure if you can get a JPG file of this, but I'm going to try. I'm just going to try and see what happens if we save it as a JPG. So I'm going to call it a bst.jpg. We'll see how that comes out. Could come out all wrong. No, it seems like it's come out as a JPG. So yeah, it looks like you can change the file type. But if that doesn't work, there's probably some way that you can make save these figures as JPG charts. So don't worry so much. But yeah, that's about it really. I just wanted to show you basically that you can resize these charts and change. Like I said, it's the ratio of the X to the Y that's more important than anything, because a lot of the time these, at the higher sort of sizes, these images end up being the same size when you save them. But what's important sometimes is sort of the X and Y sort of ratio, because let's say you've got millions of X values, or you've got 1,000 X values on sort of one chart, but you've only got 3 Y values because you've only got 3 different sort of possibilities in the series. You don't really need the Y to be very high. The Y can be extremely small, but you definitely want enough space to get a good representation of those 1,000 different X figures. So that's where you might use it. And the save thing, like I said, you don't want to manually save. Let's say you got a million, something that makes a million PNG files or JPG files. You don't want to save those manually. You don't have enough time in a year to do that probably, right? So you want them to just save dynamically. Anyway, that's basically it. Thanks for watching and hope you enjoyed.